Good afternoon. In today's video, I will be talking about geometry types in Dynamo and Revit. It's a part of the Dynamo course for beginners, and we are in video number 21. Mainly, I want to talk about geometry, and it's one of the most daunting topics in Dynamo that lots of beginners and sometimes even professionals find hard to grasp, dealing with the multiple types of geometry that Dynamo can work with. And basically I have to, or actually I'm extending or depending on my previous lecture that I have last week, where I explained the type of data that I have in Dynamo, and you can have a look at the video that I posted last week. In it I was talking about Dynamo as a type of data that we have, and we say there are numbers and strings and sequences, lists and dictionaries, and then we reached to a point where we said, or I said, that we have something called geometry, and I ran through a very basic and very quick and short list of them, and then I jumped back to the rest of the types of data that we have, and then go back again to mention quickly that we have something called Revit element, which also can make also lots of types of geometries, but in a different environment, which is a pure Revit environment, not inside Dynamo itself. So what I will try to talk about in this video is what we can model as a geometry. So I'm not going to talk about the image processing or the planes and coloring, all that topics, dimension, making views, everything. Lots of things that Dynamo actually can do as part of the data that we spoke about last lecture, but I am more specifying myself here to talk about only geometry. So as an overall, geometry is really concerned, if we try to define it or try to understand it, really concerned about how you make shapes and how you make forms, and of course how later on how we can get benefit out of those forms and shapes inside the Revit environment if you need it actually to be sent to the Revit project environment. This is one of the topics that I really wanted to talk about, and I think it might last for more than one video. I don't know. I think it will go like 2 or 3 videos, and I myself, when I was learning Dynamo a couple of years ago, I struggled a lot trying to understand the variety of types and why when you model something in Dynamo, like you really got frustrated, it's not gonna get as what you want into Revit, or it's not gonna correspond. Revit will not correspond to what you did in Dynamo, and so on. And you really get with this sad face that you see here in this picture, and you keep wondering why my model or why my Dynamo is not working as as other software or other modeling software is actually does. And to answer this question, you really need to dig deep in a lots of topics. You need to understand carefully what type of geometry we have in Revit and Dynamo together, and to distinguish between Dynamo geometry, pure Dynamo geometry that you can make inside Dynamo, whether it's in a core engine or whether it was inside Revit or not. And then what's the difference between it and, let's say, Revit elements, or actually Dynamo dash Revit elements, so the Revit elements or the Revit nodes available inside Dynamo, and also the important geometries. So understanding those types, or these types of nodes, or these types of geometries you have, will ease the pain and increase your confidence to know why the model is not working as it should be, or what you have to do to get a specific type of model. And understanding this, trying to solve this issue really needs you to understand the geometry itself as a one part, And the second part, you really need to know how Revit actually categorizing everything, how it's look at the geometry, how it categorize these geometries, Revit views, and the overall process that run through Revit and Dynamo in order to get the final geometry. All these elements, so you cannot separate Dynamo geometry from Revit itself. You really need a working knowledge of what is Revit, what is the views, what are the units, how it's actually categorizing the model, the type of platforms you have. All these questions I'll try to answer within this sub-series about geometries. But this is how I categorize it. You need to understand the geometry from one layer, and then look at Revit and how it's actually deal with viewing, categorizing, modeling units, and all that stuff related to Dynamo itself, so you can have a successful job in Dynamo Revit. And as I said, as I mentioned that in the first slide, if you need to understand the geometry types, you will encounter mainly three types: the pure Dynamo one, and the Revit elements, and the imported geometry. I'll try in this video to focus quickly, or trying quickly on to introduce you really to the to the main Dynamo geometry. They are very obvious, and I within through this course, the basic one and the previous one, you also can find a previous playlist called Dynamo in my channel that I scatteredly explained almost every one of those, I think, except mesh. I'm not really into it, but here I am showing you the differences and how you can quickly model each one of them. Basically, this is the main category. So when you say Dynamo geometry, you're talking about either points or curves and surfaces, solids, and mesh. So if you point, this is just a single point. If it's curve, though it mean line, normal curve, arc, and polycurve, and lots of other types I'm going to show to you here in this presentation. Surfaces, of course, that have 2D surface or 2D plane. It could be like this rectangle, or it could be like any complex surface, and it have to have like a mesh, like a canvas, or like a material that can block or can receive a specific texture to it, and causing us to see a solid part or like a canvas shape, while the solid is like a ball or like a box. So it has more than one surface on the geometry met and created a solid geometry that we can benefit or model or create in a 3D printing, or just send it to Revit to see what we can do with it. And the final category is mesh, and it has its own nodes and it has its own structure inside Dynamo. So let's go ahead and see how that can be applied in Dynamo. So first thing, and the most easiest one, is points, and they are either by finding the most famous one is the XYZ points, or you can depend on the UV coordinate system, which I explained or I show actually in the previous lecture, to specify a specific location that have XYZ again on any other geometry, or just free in the cyberspace. So all what you need to understand the point, that it's just a location. It doesn't have dimension, it doesn't have length, width, height, volume, nothing. It's just XYZ. It's just a group of numbers of coordination that is specified related to the Cartesian system, that specify a location or a point location that will later on can be established much more complicated geometry. So I think the point is self-explained and easy, and this will be our first category. And I posted like 15 or 10 videos in this series only just about those points, how you make them, what type of category you can make, the cylindrical system, the spherical system, the spiral system, everything. I think I covered lots of topics. You go back to the Dynamo course for beginners, a couple of, I don't know, 15 video, like 10, I don't know, all of them talking about points. Now curves, now the term curve always trigger the feeling of curvature and, you know, not straight lines. I know, because that's how that's what the English vocabulary translate to our brains. But here in Dynamo, it means all those. It means line, arc, circle, ellipse, polygon, NURB curves, and polycurves. And that's kind of annoying to remember all that types, and even annoying because each one of those will be, you know, when you look, you don't see the end up result of the line node is actually creating a curve, sorry, and that's just to increase the confusion in our brains. So they just write line here, and the line, as you know, is just 2 points or just 1 point being pushed in a specific direction and stopped, and that's just a piece of line. And it's, you know, I'm not going to define line, but the funny business here is that how you know, prove that this guy is just a curve. You just write curve, you know, just write call any function for it, and maybe point at parameter, the one that I like. All right, and you see that the line or this node will have its input and it need curves, and if you fed that to it, all right, you will find, and I don't know what I want to do is just add a slider maybe, and here we go. That's a slider from 0 to 1, has a max value, and I'm going to connect this guy here, and notice when I move, it will just make a point that's run through that curve. Okay, so yeah, if you are confused, it's okay. I was confused at the beginning, and it's okay. So just think it that way. Lines, or all type of lines, straight lines, are part of curves in Dynamo. And the same thing with the arc as a category. So if you fed it to this again, you will find that, as you can see here, moving this dude will, you know, by the way, 0 here means the beginning of the curve, for those who doesn't know what I'm talking about, and 1 will be the end of the curve. So 0.5 will be the mid, 0.25 will be the first quarter, blah blah blah, you know. Anyway, so the line, in case if you don't know what line is, it's a node that, or object, geometry object, that can be defined by 2 points. That's point 1, the beginning point, and that's the second point, which is the end point. Start point, end point, and that's here you see start point, end point, and of course they need coordination. Go back to the previous lectures if you want to know what points are and how they works. The second thing is arc by 3 points, and there is lots of other types of arcs. I'm just ignoring them. I'm just having this one as an easy one, and it defines start points, as you can see, and this one is the midpoint, and this dude is the end point, and then you combine them as first, second, third, you know, input value to get yourself an arc. And as I said, it is, you know, just a curve or a point or a type of a curve, and the evidence is that you can just connect it to this curve.point, apply any function for it, and you can get it what's the curve, all the curve category actually does. So this is the arc. Now we're gonna get to the polyNURBS and polycurves. So for the polycurves, just basically I'm having here 4 points, so 1, 2, 3, 4. And when I applied PolyCurve.ByPoints, so you have the input here. When you say by, it's a constructor, so it's assuming, or it's, you know, build its geometry based on 4 basic point geometry, 1, 2, 3, 4, and the availability of those 4 should be in a points. See here the S for the plural. That's important to have a look at. Lots of people just ignore. It's here as a first point, so just 1, and you know the line here, start point. Careful with the singular condition and plural condition in Dynamo. I know, pain, I know. You know, like it's a, because here it's expecting, you know, to have a point, so you have to create a list. Just get list.create, keep pushing this cross, have an item for each you know, point you want. Now you have points, and you send them to the points category, and you get your polyline. If you work in AutoCAD, it's just a polyline system here, and it has that done for you as a continuous geometry if you click on it. If I unhide this one or just remove that from the preview and just activate the NURBSCurve.ByPoint, let me have a look at this one. And you will see now we're going to get NURBS, a non-uniform rotational BSP line, and it created a smooth curved line that run actually through those points. And that's what we get from NURBSCurve.ByPoint. Let me turn that one off, and we check the NURBSCurve.ByControlPoint. In this one, the point you provided are not actually the point that the geometry will run through, except of course for the first one and the last one. And this one will acting as a controlling point that you can, with a degree of pressure, if you change that, I think it's just force between 1 and 3 as a values, not a much of option you got. You get less curvature, less closer to those points or more closer to those points to create this type of controlling point NURBS, which is, by the way, a different structure from the normal curves. They should add a normal curves rather than NURB curves. The normal curves are simpler and they are easier to be digested by the machine that we have. Anyway, they added just curves. So those, all of them, PolyCurve and NURBS curves, all of them actually parts of the curves. So if I go back to my presentation, so line, arc, circle, also ellipse, polygon, and are just another types of curves that even more confusing. They are shapes. As far as any human being study any type of software in the universe, so we also get the feeling that they are not curves. Sadly they are, by the way. So if I have this again, which is a function of a curve, and I get the circle to it, come on baby, you will see that my innocent circle work as a curve, which it is, by the way. So that's sad how they categorize it that way, but that's the way it is. So the circle, the rectangle, the ellipse, the polygon, the regular polygon, and the free-sided polygon or Polygon.ByPoint is or are actually all of them curves, whether you like it or not, whether I like it or not actually. Now the circle, what is need? Quickly, it's need a center point. That's the center point, of course. And this type of circle, because it's by center and center point and radius, and it gets a radius value to get this circle done. Now the rectangle, quickly, it's need also a point. This type of rectangle, by the way, there is a different type of rectangle, different type of circles that you can look here in the search bar. This one that I prepared specifically, it's need rectangle by width and length, so it's need a plane. So I created the plane by origin and I hide it. I don't know, I didn't want to show it, so it will be more confusing there. This plane, and the center of the plane, or actually plane, is the center point, which is the point, which is the center point of the rectangle, and of course a width and a length, and I gave them the same value exactly. Ellipse, my dear friends, probably I need to zoom in to get some mercy to our eyes. Too far away, huh? So that's the ellipse, and again, it's need a center point, and it's need a value in the x-axis, a radius, and a radius in the y-axis to get this thing done. Polygon, this dude need a regular polygon. It's need a circle, of course, to create the inscribed or circumscribed relation to it. So you have a circle, so as if you are drawing a circle, center and a radius, and then I just hide it because I just not interested in the circle itself. And then the polygon, which actually obviously needs circle, and you can feed the number of sides. So if you want 3 sides or 4 sides. Just click that and this dude will change its appearance. Alright, and then the last type is this dude, the non-regular polygon or Polygon.ByPoints. And this guy is one of the best I like, and it need 1 point, 2 points. You can make it even with 3, I think. Yeah, minimum 3, but I made him 4. Put them in a list again because it's Polygon.ByPoints, so plural. Look at the input, also points, and the result is a polyline, a closed polyline in this case, that you can later on or easily extrude, or you can, like add a surface.patch by patch to create a surface on it. It depends on what you want to do with it, and that's almost get us rid of all the curve category in the geometry. Now we can look at the surface. It could be just normal surface that you can create by basic extrusion, or surface by patch, lots of things, and it could be polysurface or NURBSSurface. Let's dig more into that. So I took this dude here, this polygon, closed polygon, and I just translate it down. I just move it down or copy it down or whatever, and I add surface to it. So you can see the surface is just covered those points with a canvas or a solid or whatever you want to call it, a surface here, and that will allow us, that's actually going to block the view from what's behind it and allow us to receive light and allow us to have material in Revit and all that stuff. So it's much more advanced, not like those guys have just 2D, just like wire lines or cables that's empty inside. Now this is fully solid and fully covered. So that's the surface. That's very basic surface that you can create with lots of other ways or lots of other types. I just remodeled this guy here, a bit different, I think. So lots of points. I know that's just me going too lazy to do it in a more professional way, to be honest. So we have this dude here. You cannot see it actually because this dude is on. So let me turn this one. So the poly surface is just, you are doing 2 surfaces together. That's the first surface, this one, as you can see, which is built on those points, those. And then you have another surface, which is this one. And 1, 2, 3, 4, it goes up in the z-axis, and those 2 points are common with the one located in the xy plane. So we have one surface in the z-axis and this dude in the x and y. That's what I have done. If I activate or check the preview for this guy, so this one and this one, so there are 2 separated surfaces here that I just combine by PolySurface.ByJoinedSurfaces, and I combine them together, and that created for me, if I click at it. Now that's a nice issue that always happen when you click at something, it doesn't show up. Remember that if it's a complicated geometry that built from 2 previous geometries, like this dude, so you have to turn this off. You have to turn this off because this guy is just the combination of both of those. So sometimes when you select it, you don't see it. Now when I select it, it will be blue. Some people forget this one. They always complain. I got lots of questions in the channel asking about this thing. Like they told me that we turn off this, but we when you select this one, we don't see them both because you have this one on. Don't forget the list is also a combination of those 2, so you need to turn it off. And this dude will be pure himself, not 1, 2, 3, 4 objects in the same time. Now you're going to select the poly surface. You're going to select more than 1 object. And what else? And we have the final one, which is the NURBS surface. they are, you know, this one, they are way much more advanced, and they allow you to create seriously more complicated geometry. They even structure differently. They are expecting an array of points. So here we don't deal with 4 points or with the external perimeter point or the batch point, whatever you want to call it. So here I'm just creating points, and I use it just like an array, and then I use that to create the surface. So it's like like a UVW of a point, sorry, UVW, yeah, or a mapping system for those grids that will define the structure. It can almost define any type of a complex geometry, but the point is that the structure of it doesn't need 4 per meter point, but rather than a grid of points to define more complex geometry. You can raise those points later on, and you get that like a, you know, like a canvas or like a curtain to move smoothly to create better and more complicated shapes. Okay, so this is almost it. I'm not going to talk about mesh, and the last thing to talk about today is solid. And in this solid, it's like a 3D geometry, full of 3D geometries, and those guys are, you know, I just add the basic one. You can create your own complex geometries. Solid one, so you have sphere, and it's very easy. It's like a circle, need a radius and a center point. So sphere by center point and radius, that's what we need to create this one. And you have the cuboid, which also, by the way, there is different type of sphere, so this is one of them. You have a cuboid by length, so it needs an origin or a point here in the middle of that, and it needs width, length, and width and height to create the 3D shape. We have cylinder and cone. They are almost, you can do cylinder with cones, so, but anyway. So you have cylinder, and there is also different types of that. So I'm using here cylinder by point radius. So this point, which is the lower one, and this point, which is the highest one, and then one radius for both to create the cylinder. And the cone, my friends, will be the last thing to have, and we have a cone by points and radii. So we have 2 points, one in the south, or in the bottom, one in the north, or on the top, and you have 2 radius, the lower one and the higher one, and that will define the cone geometry for you. So these are, my friends, these are the basic types of Dynamo geometries. We have lots of other ways to make more complicated. We have sweep, we have sweep, we have loft. So don't mix between the type of geometry and the modeling tools. Like the sweep is a modeling tool, but the type of the geometry you can create by a sweep. You can create surface and you can create solid. I'm here trying to say and to explain the types of geometries that we deal with, and in next video I will be continuing to show you the other types that we have. That's how we deal with the Revit elements and how they are actually incorporated inside the Dynamo geometry, and then we have a quick look at the important one, and then we try to answer the questions that we have about the errors that we see and that we got when we try to model, and what to prevent us from get a successful geometry. Anywho guys, I wish that you find this video useful. Thank you very much for watching me, and I will see you next week. Bye bye.